So now in this video, we're going to cover a circuit that I got here that is on the same sheet as the circuit from the last video. So we have the 555 timer. We used it in the last video to switch a switch. It was actually a PNP, bipolar junction transistor switch, because we were switching a load that was more current than what the 555 timer should handle. 555 timer has an input and output limit of about 200 approximately. I think it's 225 for some of them. Milliamps of current, and what I was switching was about 200 milliamps current. So I used a PNP bipolar junction transistor that could switch more current. 23904 also has a limit of 200 milliamps of current. But in any case, we are going to look at another reason why you might want to use a transistor. So right now we have 5 volts powering the circuit. Good, I can get it dark enough. If we get it dark enough, the blue LED lights up. We get a low output right there. And so we just need like that red LED to show that the output is high for the most part. But that's because I am using 5 volts. On the sheet there, I got 3 volts to 4.2 volts. So that would be a lithium ion battery range that normally you would use 4.2 volts fully charged. And haven't really looked at them in a long time, but I'm assuming I put 3 there because that's where you would likely stop using them to discharge them. So in any case, just using a single cell. So we got 5 volts. If we go to 4 volts, still we got the red LED up there. It's being fed directly from the output. Not doing too bad, you know, it got dimmer. This one probably got dimmer too, but we also have less supply voltage. So it makes sense current would go down a fair amount. But here, now you can see, this barely has current trickling through it. And we have, 3 volts, which is enough to light the red LED decently, even with the 220 ohm resistor. We could go lower on resistance and get that brighter. Probably somewhere around 6 milliamps of current. But that's the total circuit right there. We can also make it dark, and you can see the blue LED. The output goes low, a lot better than it goes high right there. So probably about 1 milliamp of current maybe flowing through it. And so blue LEDs are naturally brighter than red LEDs. That's something to be aware of. One thing I can do is take the blue LED out and put the red LED in its place, and we'll see how it does when the output's low. I just color code that we have a low output there. So you can see, even there, it's not doing, well, it's a 1000 ohm resistor. That's right. So that makes sense. Let's pluck this one and then put the 220 over there. Hopefully I don't short something. You really don't want to be rewiring while the power's on. Okay, so I think I got that right. For some reason, it is not getting dark enough. Did I pull the wrong? No, I didn't pull the wrong resistor. So this, oh, I see what I did. I stuck it directly to the power supply rail. That was the problem. So there we go. Yeah, you can see they're about the same brightness right there. And you can see 6 milliamps, 5 milliamps, and they're not changing all that much. Maybe we're on a borderline 6 or something. Or, might be a little more drastic. But in any case, main takeaway was, we can, right now output's low, that red LED, it's being sunk to ground. 555 timer does better. We already saw that when it's headed to ground and the output has to provide a positive voltage, that we're not going to get to the 3 volts. So we'll look at this again. We have the output there. Can sink enough current to light an LED source, enough current to light an LED, as long as you have enough source voltage. So we got, let's say, 3 volts here. We're going to lose about 1.5 volts when we get to the output, just because of the way the 555 timer is. It connects to ground really well. So even at 3 volts, we got 3 volts across that load right there. And with the output high, out of 3 volts, maybe it's only like 1.5, maybe even 2 volts if we're lucky. We don't really need any current, but the the red LED needs about 1.5 volts just to conduct at all, and then as current starts flowing, it needs closer to 2 volts. And if it didn't need current at all, maybe we could easily get 2 volts across it, but since it was so dim, I'm pretty sure that the output was given about 1.5 volts. So if you got a circuit that's only going to get down to 3 volts, no point putting this right there. The output, though, we can attach a resistor there, and I grabbed a 4.7, that's what that is right there, kilo ohm. So the K just moves over to replace the decimal point, because you might not see the decimal point. But when you look at the pack that I got, you know, again, you might not see a decimal point there. So they got a K where the kilo ohm is. So 4,700 ohms of resistance, because we're only working with 3 volts. When I'm like 5 volts, I use about twice the resistance, 10,000 ohm resistance, and that's usually plenty fine to turn the transistor on enough to light an LED. So the 3 volts here now, if the transistor is off, of course it's not conducting. There's no voltage difference. The LED will be on. We get a little bit of a base current, and that's all we need from the positive supply. So even though we're working with maybe only about 1.5 volts, 2 volts if we're lucky over here, it's pushing a little bit of current, and that's all you need. You need to get above 0.6 volts, and then after that, whatever the current is flowing through, if long as there's a relatively decent amount, that's going to get the transistor conducting fully. It just has to conduct better than what the load needs it to conduct. The load will limit the current at that point. And so when the transistor is on, we should have about a full 3 volts across the load right there, whereas we might only have 1.5 over there. So now I wired everything back up. Hopefully you can see all those connections pretty well. Again, this is the pin number 2 right there, the trigger pin. When it gets a low voltage, it sets the output high. So it's always telling the output to go high, but the reset pin is the more powerful pin. So when it gets a low enough voltage, I cover this up, makes a better connection to ground, pulls it down below about 0.5 volts from earlier testing. Then it forces the output low. Low input to reset pin always holds the output low. It's the most powerful input pin. So we will turn this on, and we will take an actual measurement. So the supply voltage, it says 3.1 volts. We'll probably lose about 0.05 volts. Oops, that would have been backwards, but that's okay. But there we go. Yeah, a little bit less than 3.1 volts right there. We will go first to the output. So I want that in relationship to ground. I can go anywhere to the negative rail. And so when I press the components, it might kind of shift stuff. But yeah, there you can see we got about 1.75 right now. And really, this is probably not going to throw it off. That was hardly taking any current right there. Whereas if we remove the red LED, maybe we will get to 2 volts at the output. Well, the output is high. And there we can see, 2.7. It's actually almost getting to the 3 volts. So just having this LED is really throwing off the output voltage right there. So if we were sending this to other circuitry that has an input that doesn't need current, then we, at all, like an op amp, then we could actually get, pretty close to the 3 volts right there. Now, let's get the 4,700 ohm resistor again. And I didn't really plan this when I plucked it, but let's see how quick I can get this back in there. There we go. Now the output's high. Let's see what we got for a voltage there. Okay, even that little bit amount of current is pulling the voltage down. The red LED up here is completely gone. So even this little bit is pulling it down. So that's kind of interesting. Now, I thought it would be doing at least, better, than when we had the other LED. But there you can see we got the full 3 volts across the load, unless we set the output low, which interestingly enough, now we got a negative voltage. Yeah, it's cut off there. There's probably capacitive effect somewhere. There's a little charge that got built up in there, is my guess. But in any case, there you can see we got like 3 volts right there. So yeah, it's not a super simple circuit, but I covered this a lot in recent videos. The light dependent changing the state switch both with the 555 and with the op amp, tying this to the negative supply to always try to keep the output high, but until this one forces it low, and all these other stuff are like topics, but now we kind of combine them together. The point of this video, in case you forgot, was we're working with a relatively low voltage right there, 3 volts for this integrated circuit. So it can work with this low voltage, but you got to remember its limitations. Now it can't even light a red LED from a high output. It could with the low output though. So if you also want to work with the high output, you're going to have to use a transistor, and maybe in this case the bipolar junction transistor might be your best option, because other transistors kind of depend on a certain amount of voltage for them to operate properly as well. So that may be one reason why they're still popular. I don't know. But in any case, hope you enjoyed. Make sure you check out one of the other videos I posted on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.